Today we're going to see the concept of the test that we we use for systems and understand the concept of the steady state errors that occur. Steady state errors are the, in systems are what we would like to correct using control systems, or we would like to test the systems and find out what kind of steady state error it has. So let's take a look at these test signals that you see on the screen here. And what I would like to remind you is, if I can write over here what the concept of a transfer function is. A transfer function is always the output of S over the input of S. It's a relationship between these two. From here, it follows that the output of a system in reality is the transfer function times the input, right? So what we would like to do today is to study what the output is by giving a certain input. And so happened that this input could be a step input, like a function like this. That's a step function. Or it could be that our input is like this, which is called a ramp. So step, this is the ramp. Or could be a function like this, which this would be a parabola. Yeah. Now you see, if you do the step input, you have that the input, the time function is like, step like this, go 1. Values like that, just step input. And the Laplace transform of this function is 1 over s. So it has it's like it's integration basically. So if you have the transfer function concept, the output of s is going to be the transfer function times 1 over s, see? And this is what we have to study. In the other case, if you put a ramp here, you have a constant velocity here, and um, in this case a constant velocity, and then the function would be t of time, and the Laplace transform of this will be 1 over s squared. So this is like okay, so for a parabola you have like a constant acceleration. This would be 1/2 of t squared, and the Laplace transform with 1 over s cubic. Okay, so in this particular case, whatever test we perform, we would be looking at the different type of applications, different transfer functions that we want, depending on what we would like to do. So for example, the test input for a geostationary orbit. So this is a position. If we are seeking for the position, that's one application. This one, for example, this would be a velocity test. If we want to do the velocity, or if you have a application like a method, for example, this would be the acceleration. So depending on the application that we have, we could use different test signals. The basic concept of a steady state error is this. You see, if you have a if you test the output to track the input, if I can make it like with a step input is like, okay, if I were to superimpose the input in here, okay, and the output is the same as the input, we're gonna be on this horizontal line right here, right? See, because my red line is my input, the other one would be the output. So if the output responds like the output 1, and this would be zero state error, right? But in here, if the output is like this, and this is the steady state condition, so a steady state condition. Same thing, what's steady state condition? On this one, this is your error. So there would be the steady state error. Okay? So we are testing it with a step input here, and we do with a ramp input in here. So if you have the, you see, how can I say? In this too, I think I need to superimpose the, doing this. If the input is like this, and the output is like that too, there's no error, right? But if the output is not like that, then this difference here, this is going to be the steady state error. So we have devised different tests for different applications to study this kind of error in here. So if we have in here the output 3, you know, the steady state error now would be measured. How would we measure it? That one, we would have to measure it like this, right? For this output. All right? So that's the idea. Is chapter 7 is talking to you about doing tests of the system. We normally here we could just calculate the error, but normally for the feedback control system, the way we want it in here is the way we use in control. This is your system right here, feedback here, yeah, and this is the comparison here. This is your set value or set state, you may say, let's go say value here. And this is actually the error. See, this E of S is the error. Now, what you do, we saw in a previous video the kinds of controllers that we would want to put in here to correct this error. Okay, but this is the basic loop just to test the steady state condition. Yeah. So you have in here in A, you could say the error for a step input, and if you have the if you correct it by 1 over s, this in this case you would have zero steady state error. So these are the depends on the transfer function, right? Depends on this I think it would be helpful if we can take a transfer function like this, and let's just give it this kind of test and see if this makes sense. So what I'm saying is that this is the your system transfer function, right here. But if you give it, let's do this. Let's call it TF, um, or perhaps G of S, yeah, because that's how I would like to define it in MATLAB. So we could enter in MATLAB a transfer function G of S equals to 120 times S plus 2 divided by S plus 3 times S plus 4. When you have it in factors form in here, you know that the zeros here, the zeros, you have like S, the 0, 1, let's say, this is at minus 2, right? And the poles on this, we use the word, say P1, let's say this is minus 3, and then P sub 2 would be at minus 4, right? So what I'm trying to say to you is that the moment that we make it a step response in here, what we are doing is we are obtaining an output, let's say, that is output of S is going to be 1 over S for the step input times 120 times S plus 2 divided by S plus 3 times S plus 4. So let's give this a try in MATLAB and see how we do this, okay? So let's go over here. And then we'll go and run MATLAB, okay? And we need to have the transfer function with us on a window in here so that we can have access to our transfer function. Okay, how do we do this when you have this the definition here of this? First of all, the way I think is best is define the variable S as a transfer function type of the variable of the symbol S, like this. So if you do this, the computer sees that wherever you put the symbol S, you are talking about the transfer function type of element. So the numerator of this, I'm going to say the numerator is going to be 120 multiplied by, and then you write it like this, exactly as you have it. S plus 2, like that, yeah. And then you, did I do something wrong? It's not 130, it's 120, right? So let's just fix that for now. Okay. And then the denominator of this transfer function is going to be, you put it S plus 3, close parentheses, and then you put multiply by S plus 4, see? And then you have this. And then we're going to define what G is. G is the numerator divided by the denominator. You see? So you have this transfer function now. If we go and say step of G, this then we obtain the 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 response, you see. So that's the way we get the step response to test, you know, what the steady state error is. You could also test this with a ramp. So let's go over here, say ramp of G, like that. No, I think we need to remember to test it with a ramp. We have to multiply the transfer function by it's like 1 over s squared. It's as if we have the step times 1 over s. So in this case, you'll... Okay, so right now what we have is that we have the G was the definition of G. It was the numerator, and then we want to test this with the step. And of course, here's what we have. But if we want to test it with a ramp, we have to multiply by 1 over s, and then, you know, it's 1 over s squared, really. So one way of doing it that it would be easier to implement in here is define a new transfer function, g sub 2, which would be g times 1 over s. It would be 1 over s. This is the new transfer function, g2. But if you do again using the same function step like that, it's like the original transfer function multiplied by 1 over s squared. Excuse me, I did the same thing. So we need to step of G2 is what I mean, which is there, and there you see the ramp. Okay, so this is how we can test the different systems with different inputs.